the normal distribution. All right, so imagine for a moment that you saw this graph. That's called the bell curve. And pretty easy to tell that half of it's to the right of the line and half of it's to the left. And if we said this was shoe sizes, in here the average shoe size might be at 10. Do you remember talking about this and standard deviations and those kinds of things? All right, so let's say that the standard deviation in this room, that's this little funky sigma thing, is 2. Would you please make the 1 mark on either side? Let's see if you remember that much. Now label the 1 mark on either side. Don't just draw a line there. Brandon, I think you know this. What would this line be labeled as? No, that's not Q1 and Q3. That's different. Those would be quartiles. Then that's a different thing. All right. Maybe I never taught you guys this.
It's like 12.
This is 12. You are correct. How about this over here? 8. Yep. Did I teach you this or not? Yeah. Okay, good. All right. So that means that between 8 and 12 is most of you would be in there. Your shoe size for most of you is between 8 and 12. Some of you are out here. Some of you are out there. But most of you are in the middle. Do you remember what percents that was? What percent of people are between 8 and 12?
68.
68, very good. This would round to 34% for this little part right here. And then this other part right here is another 34%, making a total of 68. Is that ringing a bell? Okay. Now, do you get that a calculator could probably figure out how many people are between 9, which is like not 8 or 10, and 13? Like here's where size 13 shoe would be, and here's where size 9 shoe would be. And a calculator could probably figure out this. That's what I'm going to teach you today. And you'd have to tell the calculator what the average is, 10. What you want to know, like I want to be between 9 and 13. And what one last thing do you think the calculator would have to know? Standard deviation. All right. So this is called normal CDF. And I'm going to help you to do this for our classroom. Your average shoe size is about a 10. Your standard deviation was about a 2. And so we're going to figure out what percent of you are between 9 and 13 with the mu at 10. This is the average. Really, technically, you should say the mean, because weirdly, the word average doesn't necessarily mean what you think it does. I thought for a long time that average was just one thing. Just one thing is the average. But technically, you can use the word average to represent more than one thing. Mean is one of those things. So mean is a little more accurate. Mean is the word that really means add them up, divide by how many there are. But average actually could mean other statistical representations of the middle of the data. So the word average doesn't mean what you think it means. The word mean does. Okay, so this, I shouldn't put average, because that actually could mean more than one thing. This, it needs to know the mean. And last, we need to tell it this, which is the standard deviation, which is going to be 2 in our case. So we got to tell the calculator these 4 numbers, and that's all it needs. And it can tell you what percent of the people are in there. Okay? And what we're doing again is this. We're saying that's our average down the middle. We want to know between 9 and 13. See, between 9 and 13. All right. So we clearly have to give the number the calculator these four numbers, do you think the order you give it to the calculator matters? Yeah, it's going to have them in order, in the right order, and I'll show you what that order is. All right, there's the big picture. Now, let's talk a little more fluffy, easy stuff for a while. Does this look like the normal distribution? No. Does it have, the peak isn't in the middle. Are there some things that are distributed this way? Yes, there are. I would submit that maybe IQs in this class are a little skewed. Because why? Because this is an honors class. And so there's not many kids in here who are below average IQ. There could be, but there aren't going to be many. It's not going to be a normal distribution. Don't point at each other. That's not nice. Okay, so do you get that this, which feels to me like it's been shifted to the left, is called skewed to the right? Isn't that weird? It's counterintuitive. To me, I swear, that seems like skewed to the right. What does this say right underneath it? Skewed to the left. All right, so get used to how those are the opposite of what you would think. This is not skewed, but it's spread out randomly across the graph, but it does not look normal distribution to me. Why? Because like the beginning of this is like super high, and the middle isn't super high. Normally it's supposed to look like this. It's supposed to look like a bell. And that doesn't look like a bell at all. The point is this. Could I load this room with a whole bunch of people that have really big shoes and skew my data? Yes. And what we're doing assumes you have a big enough population and randomly chosen so that the data isn't skewed. It's got to be a normal, otherwise what we're doing won't work. It's called literally normal in the name of what we're doing, normal. So if you mess with your data, you can get results that won't work because it's not normal. That's kind of what's normal. If you get enough people in your group and you randomly select them out, then this is kind of what shoe sizes would do. All right, in this case, what is this about? Doesn't even say. It says a normal distribution, and it doesn't say what any of those are. It's definitely not IQ. All right. So this sort of looks like a bell curve. And that sort of looks like a bell curve. Which one wins? This one is the normal one. The one that's really spiky in the middle there, that means that they're all kind of squished together in the middle. Do you get that? Means if it's about shoe size, that we have almost everybody has the same size shoe? You could do that. You could load this room with people that all had pretty close to the same size shoes, and it would spike like this. All right, moving on. The mean equals the median equals the mode. Whoa. Does that happen very often? Actually, it does. If you get enough data, the mean and the median and the mode are all the same on a truly normal curve. The mean will be right in the center of the graph. It'll be symmetric, meaning there's symmetry here, right? 50% will be above it, 50% below it, and it's spread out based on the standard deviation. Again, one standard deviation out contains about 68% of the data, etc. Okay, moving on to this page. Remember these numbers? 68, 95, 99.7. Those are the exact numbers that a stats teacher would expect you to know off the top of your head. Those are like minimum. You should know that. I would memorize those. I really would. And I said it was about 67% when first time I told it to you. I'm wrong. It does round to 68%. But the way to think of that is it's about 2/3. Because do you get 2/3 is exactly 0.666666. And that's really close to 68%. It's not 2/3 of the people. It's a tiny bit more than 2/3 of the people. Okay? All right. Now, this kind of question is pretty much impossible to do without a calculator unless you can do this super intense calculation, which I'm sure you could if we trained you how to do it, but we're going to use a calculator to do it. So let's just read it so you understand. the average height of 17-year-old boys, okay, we know a few of those around here, is normally distributed with a mean of 179. Okay, that's important, know the mean. Standard deviation's 8, gotta know that, that's cool. Calculate the percentage of 17-year-old boys who are between that, and we'll find out is that like 63% of kids are between that and that? All right, go on to the next page. Is another type of question that's like that. I think we're gonna skip over it and get to the good part. Because if they were just right on the standard deviation lines, we already talked about those. Those would be too easy. So we're going to have to do something called disturb. And that does not mean disturbed. What do you think it means? Distributions. All right. So that's right above the vars key. So take a second right now. Grab your calculator and find the vars key. And do you see right above the vars key? Do you see disturb? All right. Then get there by sitting second, distributions. You guys have heard of a PDF before, right? Do you guys get that what we are doing is not a PDF? PDF is a document form and stuff. So I'm just trying to give you a way to remember it. It's actually hard to remember if it's PDF or CDF. The ones we do are called CDFs. They're not PDFs. PDFs are like a document type. This is a CDF. All right. Now, this is the order that you need to put them in. They're going to ask you, once you get to normal CDF, which I'd like you to do right now, they're going to ask you for the lower, the upper, the whatever the heck that is. Take a guess what it is. I told you before. But what is it? It's the average. Yep. And what's that one? Standard deviation. So if I were to draw this, you don't obviously have to draw it, but I'm just going to try to show you. They gave me the average would be 10. The standard deviation goes out 2.3 in both directions. And they want to know what percent of people are between 8 and 11. Well, 8 isn't right on the standard deviation line. It's close to it, but it's not it. So 8 goes like from here to the upper is 11, which is like here. So some weird like thing that's not exactly between two standard deviations. So we'll figure out what percent of people are in there. So go ahead and type in those numbers. On lower you type 8, upper you type 11. Now, some of your calculators need you to type it like this. Please raise your hand if yours didn't give you this list. Okay, you have the old style calculator. You've got to type it in just like this. You've got to know that the first thing that you're giving them is the lower, and then the upper, and then the average is here, and you end with the most important one, the standard deviation. And once you hit enter, you get 0.4758, 0.47587 technically. So now I need to know where to round it to. Well, it all depends on what the teacher asks for. Probably a lot of times we deal with 3 places. Would 0.475 be right? Would it? No, because that's an 8 after it here. And so 0.476 would have been right. And what does that mean? About 47, maybe even round it to 48%, about 48% of kids in here, if the average shoe size is 10 and the 2.3 is the standard deviation, we were using 2 before, about 47% of you, 48 maybe, would have shoes between 8 and 11. I actually want to see. You know whether your shoes are between an 8 and an 11. Would you please raise your hand if your shoes are an 8 through 11? And that looks like about half the class. Look at that. Isn't that cool? All right, thank you. All right, now, that's it. I know I went really fast, But I'm going to give you a couple problems now to see if you really got this. And it can't always be like something that we all can relate to, but obviously it's the best if the data is relatable. So I'm going to ask you this. How many times you've had a piece of pizza within the last year? That's going to be really hard. Let's go with month. How many times have you had a piece of pizza in the last month? So if you've had it every day, that'd be 30 times. I don't mean like how many individual pieces of pizza you've had. I mean, how many times have you sat down and ate some pizza in the last month? And if you have to, think of it out as a week and then go, okay. And then I did that 4 times for a month. So, okay. You got a number in your head? All right. So how many of you are at a 0? Haven't had any pizza in the last month? All right. How many of you are above 10? Raise your hand if you're above 10 times you've had pizza in the last month. All right. So then obviously somewhere in between 0 and 10 is our average, right? Then if it's below 10, I think you could hold it up on at least 1 or 2 hands. Would you please hold it up? Like if yours is a 7, you'd have a 5 and a 2, on your hands. Okay. So I'm going to try to average these numbers you guys are holding up. Hold up a number. Play along. All right. I'm going to average these in my head, adding them all up and dividing by how many there are. All right. It looks like our range is between 9 and who's got the lowest? We got a 1. So our range is between 9 and 1, but I think our average is about 4. And I think our standard deviation, there was a big variety. I think their standard deviation is 3. Now, I'm going to tell you, not in order so that you have to figure that part out. You got to go back to the notes if necessary. I want to know what percent of you were between 2 and 8 pieces. There's the 4 numbers. You should know what order to put them in. Take a second. You should know what's under VARs, which is under technically distir for distributions. Raise your hand if you got 0.656. Awesome. Yay, you learned something new. So today's a good day to start doing some reviewing. Box, that's a good question. I'll tell you about the test in just a sec. This is a box plot. Can you please write this down and use the correct name for all 5 of those numbers? Now, as you've been learning this stats, some of you may have been smart enough to process that we just did a cumulative test before this test. And then the cumulative tests are the retakes. And if we start a new unit right now called stats, and you have a test on it, and the only retakes are cumulatives, then there would have to be a test on stats, a whole nother unit and another test, and then a cumulative test on all that before we get to the final. And yet, we're at the very end of May. So how's that going to work? It's not going to work. And so what do? Is there just no retakes on this next test? No. There just isn't a next test. What? What this means is that the stuff you're learning on stats will be on your final, but it will not have its own separate test. Okay, so your next test isn't until the final. Okay, so you don't have to worry about a stats test, except that there's some questions on stats on the final. Okay? Now, if you're disturbed about that, distribution, anyway, dad joke. If that bothers you, the cool part is that final is only worth the same as a normal test. So your grade's not going to change too much from here. But I will say the final will be harder than a normal test, but it'll count the same as just a normal test. All right? Now, why is it harder? Well, because it's got some things on it you've never been tested on, stats, and it goes back through the whole second semester, so everything from mid-January till now. And I guarantee you there's some things you forgot in there. So we'll be having plenty of a chance to review for it, but it only counts like a normal test. All right. Then, one more thing, homework becomes more important than you think. I'm going to give you one more reason to actually do your homework for the next few days, because almost everybody in here is within 2% of either the grade above them that you'd probably all hope to get up to, or the grade below you where you could drop to. And then one last test, if that last test turns out to be a C, if your final is a C, almost anybody in here, it would drop you a grade because you're only 2% away from the grade. Now, there's a few of you. There's a few of you that have locked in such a high percent by this point, and you know who you are. If you've pulled off like 98%, well, then you could probably get a C on the final, and it probably wouldn't bring you below. You might have that situation. And if you've got that far, yeah, you've earned it. You have a nice coast to the end if you already have that high of a percent. All right. I still expect you to try and do your best. Okay. So here's one of the questions from, well, it's not the question on the final, but we usually have something like a box plot on the final. They're a big deal. Did you know this was the min? Did you know this was the Q1? Did you know this was the med? Just to clarify, that is not the average. It's the median. This one's Q3, and this one's max. I said there was one more supercritical besides these, and it was the what? It's not on here, but it's supercritical stat. Not the range, that's too easy. Standard deviation. Do you remember the symbol for it? Yes, definitely that one. That one's the standard deviation, and it's not on a box plot. But if you had that, you'd be able to do the normal CDF like we just did. See, if you have the average, that would also be good, but a lot of times the average and the median are very close to each other. Do you remember me saying on a normal distribution that the average is the mean, which is the median, which is also there was the third M word, mode. The mean, median, and mode are all the same. Crazy. If it's totally normally distributed. All right, and then that does bring up, somebody brought up range. Range, and kid writes 3 minus 12 or 3-12. Oh, so sad. What was the right answer for range on this thing? 9. You can't say two numbers for the range. The range is actually when you subtract them and you get 9. How about the interquartile range? Say it if you know it. 3. Okay, focus. I'm glad you're doing well. That's great. But the interquartile range is another thing on your test. You would subtract those two. All right. And what I just taught you, let's see if you still have it in your head. You go and gather a bunch of squirrels, as one often does, and you weigh them and you get an average weight. I want you to tell me, what do you think the average weight of a squirrel is? We're doing it in pounds. Pounds. How many pounds do you think a squirrel is? And I know some of you are like, I don't even know what a pound is. Have you ever picked up a block of butter? A full block. That's 4 of those little rectangles. That's a pound. a block of butter that weighs a pound. That's 4 of those little rectangular, tubes of butter. That's a pound. What do you think? Average squirrel, like 2 pounds? A small cat is like 6 pounds. It's true. It's true. Your cat is not small then. All right. All right, so, and now I'm going to change it down. It says the average squirrel is, if there's 16 ounces in a pound, is going to be 32 ounces. Okay. Next, I'm going to say the standard deviation is 4. Then I want to know what percent of squirrels are between 30 to 40 ounces. Get about 2/3 of the squirrels. Raise your hand if you had that one right. About 66%, 67%. Nice. Okay, good. Okay, I think you get the new stuff. I think you get the old stuff. And there is some homework. It is fairly easy. Remember that homework added together counts for 10% of your grade. If you're leaving some homework out, you are hoarding your grade every single time, just a little bit. Okay, and then for some of you, it's been the difference between like, should have an A, but you actually have an A- because you haven't been doing your homework real well. Just stay locked in. Keep getting your homework done through the end of the year. It counts. It matters. Yes. You weren't able to submit past assignments. Oh, good question. Once the cumulative rolls around, they're usually locked down. So my rule is if it's open, you can still sneak it in until I can get around to All right, let's get started on the homework. I can't remember if it's a worksheet or a Schoology quiz. Which one is it? Schoology quiz. All right, hit the start. And let me get it started with you. The time taken for a skier to complete a downhill run has a mean of 45, standard deviation of 4. Okay, between 41 and 49. 41 is the first number. 49. Nordstrom, what was the third number, the average? 45, and the standard deviation? There you go. You're doing a normal CDF. Brandon, focus. We're doing the first problem of the homework. And here's our 4 numbers from the low to the high. Now, every now and then somebody has to put in like you have to go all the way from, let's say, 45 to infinity. How do you type in infinity on a calculator? If the high has to be infinity, what the heck do you do? Anybody have a theory? 1 times 10 to the... Exactly, very good. That would be like infinity. And sometimes, weirdly, you can't put in a negative super small number, and so you'll have to do like the same idea for 0. If you don't know how to do 0, I would think of it as 1 times 10, and you might be like, 1? But I'm going to go to the negative power of 99. That's pretty much 0. Now, I know, I understand how you would be like, why don't I just type in 0? Trust me, there are instances where you have to use this instead of 0. Sometimes the calculator will give you an answer that's like this and expect you to know that that pretty much means 0. Okay? All right. Then I think I've taught you everything. And that's all I got for the video for today.